Good morning, and get ready for more expressions and equations in math. Yesterday, we started looking at what expressions and equations were, and in your notes, you wrote down some characteristics of expressions and some characteristics of equations. So we're going to go over a little bit more with this and get you very familiar with expressions and equations. So as we always do, we're going to go through what you're learning, why you're learning it, and how you will know when you have learned it. So again, we are learning how to read, write, and simplify math expressions and equations. Why are you learning it? Well, writing and simplifying expressions and equations allow you, or allow us, or anyone, to be able to classify and order ideas and find answers quickly and accurately. As you get older and work with math, particularly when you're trying to problem solve either home improvement repairs or figuring out plans for a party or any number of different activities. You'll find that being able to classify and use equations or use math to help you find your answers is going to be much better than guessing and checking and either getting too much of something or not enough. Math will help you get it right the first time. Then how will you know that you've learned this? Well, you'll be able to read, write, and simplify math statements accurately. So first, we're going to do some review items. This goes to what we were doing most recently with integers and distance and finding changes in either altitude or temperature. So this first one, there is a bicyclist starts his ride at Mount Pass, 325 feet above sea level, and completes his trip in River Valley at negative 125 feet below sea level. So you wouldn't usually say negative 125 below sea level. You'd either say negative 125 or below sea level. What was the change in elevation over the course of the bicyclist ride? This is going to stay up here, and what I want you to do is open up your math notebook to the last page you took notes on. And I want you to draw a diagram of this problem. Being able to draw a diagram is one of the best ways to accurately solve the math problem that you're looking at. So we know that he starts at 325 feet above sea level and he completes his trip at 125 feet below sea level. Now, this is not a great big fancy drawing that you're doing. You're not putting trees, you're not putting water. You're doing a diagram, something to represent the height or the highest he was at, and something to represent the lowest. So take 1 minute, and you will be timed on this. Take 1 minute and do a diagram to represent this information, and then we will continue. So pause the video here and come back in exactly 1 minute. Okay, so you've got your drawing, and let's see if it looks something like this. Notice I didn't draw a lot of trees, I didn't draw a house, I didn't draw a guy on a bike. I just drew a diagram. Here's Mount Pass, 325 feet above sea level. Here's sea level, and here's River Valley, 125 feet below sea level. So now you need to figure out what was the change in elevation. Well, he started here. From here to sea level is 325 feet. To get down to River Valley, you need to go another 125 feet. So you have 325. It's not that easy writing with a mouse. And 125. And you want to know how much altogether. So the change in elevation from here to here is 450 feet. That is a combination of the 325 feet from Mount Pass to sea level, and then the 125 feet you have to go further after sea level to get to River Valley. So hopefully this is what you got. I'm sure you did, but if not, take a look at what the diagram shows. And remember, drawing the diagram can really help you figure out what you need to do. So now let's try you out another one. At midnight in Maine, the temperature was 5 degrees below zero, or -5 degrees. Over the next 3 hours, the temperature dropped 7 degrees. What was the temperature at 3 a.m.? Be careful with this one, because this is telling you the starting point, -5 degrees, and it dropped. Think about what that means. Dropped is going to indicate how you're going to move on a number line or on the thermometer. And then what was the temperature at 3 a.m.? In your math notebook, right next to the diagram that you just did, draw another diagram. You might want to do a vertical number line and indicate where you're going to start and where you're going to end. So 1 minute, pause the video here, start the timer, 1 minute, and come back in at the end of that 1 minute. See you soon. Okay, here we go. 1 minute's gone by, and let's see if your information looks like this one. So I've got a thermometer here, which basically that's just the vertical number line used to measure temperature or measure heat. And I started at 6 degrees above zero. There's zero. And this is my starting point. I highlighted in yellow. So I'm starting at 5 degrees below zero, and it dropped 7 degrees. It didn't say go down to 7 degrees. It dropped 7 degrees. So I'm going to count 1, 2, 3, 4, 5, 6, 7. And you end up at -12 degrees. Some of you, when we worked on this previously, said, well, I'm just going to take 5 and I'm going to add 7 to it because I want to know the distance that it dropped, and it's 12. Well, this is a -5. This is a -7 because it's continuing to go down, so it's further away from zero. And your answer is -12 degrees below zero. That's pretty darn cold. So here we go. Complete the following statements. You're going to refer to this number line. And I'm going to read through these statements here. Then we're going to pause the video for a couple of minutes. You're going to work together with the person sitting next to you. If you read the note on the board, it said, do not move your desks. So you are not working in groups of 4. You're working with the person next to you. If you do not have a person sitting next to you, Mrs. King will move you with someone else or let you know what to do. So you're going to refer to this number line, and you're going to complete the following statements. 4 is, and then look at where you're going to. 4 is what? Greater than, less than, equal to, 2, because. And then you have to explain why. And then 16 is what? Greater than, less than, equal to, because, and why. -4 is what? The -8, because, and why. Explaining why. -18 is what to -12? Because, and then your explanation as to why that is. So again, you're going to pause the video here, and you've got 4 statements. Let's give you 6 minutes. I want you to write the statement, and let's make it 8 minutes because you're going to have to write the statement and your explanation in your math notebook. Remember, when I collect your math notebooks to check them, I should see all of this on your page, not just 1 or 2 notes. You do not need to draw the number line. Do not spend your time making the number line. You have 8 minutes to read the statement, write the statement, and the rest of your answer, and discuss your answer with the person that you're working with. Okay? Get ready. Pause the video here, and in 8 minutes, we're going to continue. And here we go. 8 minutes have gone by. So I'm starting at 4. I'm looking at 2. And if I were to indicate the movement that I'm going here, this is going down. Okay? So 4 is what? You should have said greater than 2 because 2 is to the left. I'm going to open up a text box so I can type instead of trying to write, and there's a better probability you're going to be able to read what I'm putting down. Because 2 is to the left of 4, it is less than 4. So that means 4 is greater than 2. If 2 were to the right of 4, you'd be going in a positive direction. But it's to the left of 4, so it is less than. It's closer to 0. It's before going in a positive direction before 4, so it's less than. So let's take a look at 16. So here's 16. Here's 20. So what are you going to say for this one? 16 is less than 20. And what would your explanation be? Well, if we look at 16 and we look at 20, again, if I'm drawing the arrow that I would need to go in to get to 16, I am going to have to go from 20, I'm going to have to go to the left. So 16 is less than 20 because 16 is to the left of 20. It is less than 20. Okay, you may not have used those exact words, but it should be something along the line of looking at 16 is going to be less than, and why would it be less than? Well, it's to the left, and as you move to the left on the number line, your numbers get smaller. Now we're looking at -4. -4 is what? To -8. Well, remember, as I continue to the left, my numbers are getting smaller. So if I'm looking at -4 and I'm looking at -8, -4 is greater than -8. It's less than 0. -4 is less than 0. It's less than the other numbers that are higher than 0. But if I'm comparing -4 and -8, -4 is greater because it is to the right of -8. It is closer to 0. It is larger than -8. Okay, now we're looking at the last one, -18 and -12. -18, -12. So negative 18, in order to compare this, I'm going to start at negative 12, and again, I'm moving this way. Okay, so negative 18 is less than negative 12, and why? Well, again, I'm looking at negative 18, and it's to the left of negative 12. That means I need to continue further down the number line. The further down I go, the smaller the numbers. So negative 18 is less than negative 12 because it is to the left of negative 12. That means it is further away from 0. It is smaller than negative 12. That's why it's less than. Okay? So hopefully you did well on those and you were not tricked by any of the numbers that you had here, particularly the negative numbers. Remember, the further away from 0 you go, the smaller your number is. So if I'm comparing negative 6 and negative 10, and I want to know, and I start with negative 10, and negative 10 is what than negative 6? Well, it's further away, so it's less than. If I had negative 10 and I wanted you to compare negative 10 and 2, again, you're going to look at it's further away, so it's going to be less than negative 10. I'm sorry, less than 2. If I have negative 4 and, I'm sorry, if I have 4 and 8, and I want you to compare 4 is what to 8? Well, it's less than, because in order to get to 8, I need to go in the right direction. Okay? So here we go. In your math notebook, you are going to have, you've got 1, 2, 3 terms. You're going to have 5 minutes to write all of these terms down. Make sure that you are writing everything that you see here. If you finish early, just put your pencil down and wait quietly. Okay? So write the word and the definition in your math notebook. Stop the video here, set the timer for 5 minutes, and begin writing. Okay, you should have all of this information written down. And again, the constant is the number in equation or expression that does not change. That's why it's a constant. It remains the same. A variable is a letter that represents an unknown quantity or amount. And you can also use a variable to indicate the number of items that you have. And you're going to see in just a moment what I mean by that, because we're going to be taking a look at how you can write the coefficient and the variable for images that I'm going to be showing you. A coefficient is a number in front of a variable that tells you how many times to multiply the variable. Okay, so important terms to remember: constant, the number does not change; coefficient, a number in front of the variable. And the variable is a letter that represents an unknown quantity or amount of something. So here we go. Represent the number of cats here using a variable and a coefficient. Remember, the coefficient is the number in front of the variable. So instead of writing, there are 3 cats, I could write this mathematically by using a variable to represent the cats and a coefficient to represent the number of cats. So 30 seconds, talk with your partner and How would you write three cats? There are three cats in the language of math using a coefficient and a variable. 30 seconds, discuss. And time. And what did you decide you were going to put? How are you going to show that? Well, I decided I was going to do 3C. The variable C represents cats, and 3 are the number. So instead of writing out there are 3 cats, I'm just going to put 3C. And bam, language of math, there you go. Variable for cats, C for coefficient. So now let's take a look at the next one. Represent the number of penguins using a variable and a coefficient. How would you write out there are however many penguins you see there using a variable and a coefficient? Again, 30 seconds, talk with your neighbor, and go. Okay, so how many, or how would you write this? Well, there's 2, 4, 6, 8, 10. I put 10p. Now, I put a lowercase p and a lowercase c. If you wanted to, you could put uppercase. Usually your coefficients will be lowercase, but if you put an uppercase letter, that's fine. And again, P represents penguins, and 10 is the number of penguins that you have. So instead of writing out there are 10 penguins, I'm going to put 10p in the language of math. Nice. So let's try another one. Okay, now that you're done laughing at the funny little monsters that we have here, represent the number of freaky aliens here using a variable and a coefficient. And if you're still laughing, knock it off. And you're going to figure out how are you going to represent the number of freaky aliens and a coefficient. So 30 seconds, talk with your partner, go. And time. So there's a number of different ways you could have described this. If you put 2 variables, I'm going to caution you against that. You want to use 1 letter for your variable. So I put down 6A for 6 aliens, or 6F to represent freaky aliens. But I would not put 6AF because that would represent there are 2 variables that you need to look for. And we don't want that. You only have 1 variable and then the coefficient. So there's 6 freaky aliens, so 6A or 6F. If you wanted to do it by the color, maybe you wanted to put 6B for 6 blue aliens. whatever you decided, however you decided to represent it, as long as it's one variable and one coefficient. So let's try another one. Let's leave these little scary blue guys behind. And oh my goodness, got more aliens. These aren't quite so scary. Oh, they're even waving hi. You can go ahead and wave hi back to them. Represent the number of aliens here using a variable and a coefficient again. So when I say go, 30 seconds, figure out how many waving aliens there are and write your coefficient and variable to represent what you see here. Get ready, 30 seconds, go. And we're back. These guys are actually kind of cute. So what did you decide to put for yours? I put down 12B. And you may be thinking, B? Well, I looked at their great big blinking eyes and I decided to put the B for 12 blinking-eyed aliens, but I'm only using one letter to represent it. So there may have been a number of different ways that you decided to show it, but that was what I wanted to put down because of the blinking of their eyes that I found quite interesting. So let's wave bye to them and go on to the next task that we have here. In your math notebook, I want you to write down each of these expressions. There's 1, 2, 3, 4, 5. Write down each of the expressions. And I will give you, let me see, 1, 2, 3, 4, 5, 3 minutes to write them down. You are not drawing the circle or the square. We're going to be using that in just a minute. But you're writing down the 4. Leave a little bit of room because you're going to be doing something with these expressions. So just write them down. Leave some room. And we'll be back in just a couple of minutes. Okay, so you should have these written down in your math notebook. Now, I'm going to take a look at the fact that there's a variable and a coefficient. There's also a constant, but we're not going to deal with the constants right now. I want to really work the two terms, coefficient and variable. So I want you to draw a circle around all of the variables that you see. Even if the variable is a different letter, if it's a variable, draw a circle around it. If it's a coefficient, put a square around it. You all have this written in your math notebook. You're going to work with your partner. You've got 5 of them here. You're either just drawing a circle or drawing a square. So let's take 3 minutes to code these expressions. Circles around the variables, squares around the coefficients. You're going to pause the video here, and in 3 minutes, you're going to check back in. Ready? Go. Okay, so now let's check and see. We're going to put circles around the variables. Well, P is a variable. That's a letter that represents something, some amount. Don't know what it is, and It doesn't make any difference at this point because we're just looking for the variables. And here I'm going to put a circle around M. M is also a variable. It's a letter that represents a certain amount. And I'm going to come over here and I'm going to put a circle around the M. Notice the variable does not have to be at the beginning of the expression. It can be anywhere in the expression. If it's a variable with a coefficient in front of it, that's what I'm looking for. Here's a variable, D, and I have another variable, D, and I have a variable, C. So there's all my variables. That's the unknown amount. I am now going to put a square around the coefficient. This means 3 times P. Remember when you wrote your definition, the coefficient means the number of times you're going to multiply the variable. So 3P means 3 times whatever the value of P is. And I'm going to look for a coefficient here. And this means 12 times M, whatever the value of M is. I'm going to put a square over the 9 because the 9 is a coefficient. And this means 9 times whatever the value of M is. I'm going to put a square around 25 because again, this means, move that up a little, means 25 times whatever the value of D is. Now, I have 2 variables here. So that means I have, if there's a number in front, 2 coefficients. So 87 times D and 24 times C. So those are all my variables and all of my coefficients. Nice. So now we're going to go to another page and I'm going to have you create create 10 expressions using variables and coefficients. Include one constant. So I need 10 different expressions, and I want to include variables and coefficients, and I need one constant. So one way that I could do that is 15C plus 20P minus 12. There's your variable, there's your coefficient, there's your variable, there's your coefficient, 12. This will change based on the value of P. This amount will change based on the value of C. The 12 will not change. That is the constant. So this is an example that you can use. You can use whatever operations you want. You can add, subtract, multiply, and divide. You need 10 expressions in your math notebook using variables and coefficients and include one constant. You can put more than one coefficient and variable. You will use those as different terms. So there's a term, there's a term, there's a term. And use this information here, variables, coefficients, and one constant. So I have 2 variable terms and 1 constant term. You don't have to necessarily use 2 variable terms. But I do want you to have one constant. So pause the video here, and I'm going to give you 8 minutes. Work with your partner, come up with a list of 10 expressions using variables and coefficients. You're also getting close to the end of the period right now, so once you finish your 10 expressions, you can either work on your problem of the week, if you can work on it quietly, or read silently, or if you have work for anyone else. If you have anything for Mr. Storch, you can do that. So basically, the video is going to end here because with the remaining time, you're going to write your 10 expressions with variables and coefficients and one constant. And then once you're done with that, you're going to be reading silently or working on other homework. So good luck with this, and I will see you on Thursday.